I spy with my little eye. That is Flemish. Ik zie wat jij niet ziet. Now, I wonder how many people in this room actually still know this game. Could you please raise hands if you do know? It's actually more than I expected. I guess if I will ask this question here tomorrow, then I'll probably see less hands. But anyway, different public. In fact, it's a game. And it's a game that I used to play with my two younger sisters in the car, at the back of the car, on our way to the Ardennes with my parents. And on this picture, these are in fact my two sisters. And this picture reminds me of two other things. And basically, one is the old gray Volvo that my parents used to have, and that's the first car that I was allowed to drive. And the second thing it reminds me of is that my dad clearly wasn't the best photographer of his time. But yeah, can't really blame him. Now, we were playing this game in the back of the car because we did not have any smartphone. We did not have any tablet. There were different times. And the fact that I bring up this game is really because I think it's the perfect metaphor for the technology that I would like to present to you today. And I am Kris. I'm Kris Broos. I'm a scientist working at VITO. And as a kid, I have always been fascinated about engineering and about technologies that could bring order into chaos. Really, you should have seen my Lego collection. Nicely sorted, color by color, even shape by shape. Now that's me, because when I was young, I did not have a smartphone, I did not have a tablet. Now, let me share with you the following number. I hope it does appear on the screen. No? No numbers? Yes, here it is. 268,591,166. Do you have any idea what this number stands for? No? Okay. I see you think that's a massive Lego collection, but no, it's not. I wish it was my Lego collection, but it's not. This is not the amount of blocks. You have to think more about the tablets and the smartphones. And not so much about them, but you have to think about what's inside. This number represents the total amount of batteries that was put on market in Belgium in 2023. That's a massive amount, really. Now, this comes down to about 23 batteries for each individual in Belgium, young or old, doesn't matter. And I'll tell you, this number is actually rising year by year with a couple of percentages. So it's really growing enormously. I could say, quite seriously, batteries, they are all around us. Try to imagine a world without batteries. It's hardly impossible. If it wasn't for batteries, I probably wouldn't have been here today, or at least not in time. I mean, my smartwatch woke me up in the morning. There's a battery inside. I went downstairs, had a coffee, went to brush my teeth, electrical toothbrush, battery. Then I went to the car, opened the car keys have a battery, the car has a battery. I drove all the way here, made a couple of phone calls, all batteries. I arrived here, and honestly, this place is amazing, it's beautiful. I think most of you have made pictures for their friends back home and saying, look, look, look how beautiful it is. I made pictures myself. I mean, Really, seriously? That's what you do. Now, I do have this here at hand. And with your permission, I've never had a public this big. With your permission, is it okay if I make one selfie? I will put the result on LinkedIn. You can check it out tonight, all right? Woo! Thank you. Thanks. These are 3. Great. I'll show them to my kids as well, but you're allowed to see them on LinkedIn. Back to the batteries. What's happening with all these batteries at the end of their life? Most of you, just the fact that you're here, you probably realize, yes, they are being recycled, and that's great. And yes, they are being recycled because we need the valuable materials that are hidden inside these batteries. We have to recover them, make new batteries out of them, make other pieces of equipment. This is what we do. But how are we doing this, actually? Have you ever really thought about that? And the first step, if you want to recycle batteries properly, is actually that you collect them. We have to gather all the empty batteries, we have to bring them together. In Belgium, we do have a fantastic company that actually does just that. That's VITO. And VITO is actually having the task of collecting all these batteries and bringing them all together. And I have to share with you that we, as Belgians, we're world champions when it comes to battery collection. There's no country that does a better job in it than we are. I mean, this is partly you that's doing it, it's partly VITO with their more than 25,000 collection points in the schools of your kids. They are at the shops, they are at the waste collection parks, they're basically everywhere. And we do a great job. And then they come in this typical, for most of you that go to the waste collection dumps, they will see it, the typical green vessels. And then you see all the batteries that are hidden in these barrels. And if I have a look at them, I can see quite different shapes and forms, and that's fine. But I also can see there's alkaline batteries, there's batteries made out of nickel metal hydride, there's lithium-ion batteries, primary or rechargeable, there are lead batteries. It's a whole bunch of different chemistries into that one barrel. Now, I tell you, it's impossible to properly recycle those batteries if they are mixed with all these different chemistries into the same barrel. Now, how are batteries being sorted out? We are today in 2024. Any idea how we sort batteries in Belgium? Batteries in Belgium are sorted by these 2 guys. I'm joking, thanks for the laugh, I'm joking. It's these 2 guys and their colleagues, because there are many more guys on the conveyor belt. It's done by another great company, it's done by Sortbot. And Sortbot actually has the task to sort out all the batteries that VITO has collected and separates them out nicely, chemistry by chemistry. But it's really done by human beings looking with their eyes, taking the batteries with their hands and putting them in the right spots. I have the utmost respect for these people working on these conveyors because I've been there, I stood there. This is really not an easy job. It takes about 3 to 6 months to train somebody to work properly on that conveyor belt because the diversity of the batteries is so big. But it's actually an uphill struggle for them because quite often you cannot read anymore what's on the batteries because batteries are old and dirty. Quite often, I mean, not quite often, every day new batteries are coming onto the market. It's really that uphill struggle, it's a fight they cannot win. This is not the way that we create future-proof battery sorting. We need to come up with something different. Now, if we could give these guys and their colleagues some kind of Terminator vision or what have you, that could actually improve the situation quite dramatically. What if we could give them special eyes? Like this, that they not only see the outside of the batteries, but if they could also look at the inside? And not just look at the inside. What if they could visualize the chemistry that's hidden within those batteries? I mean, that would change the world quite dramatically for them. Now, I've been told it's not allowed to pull out the eyes of those people and replace them by some bionic eyes, and so we had to come up with something else. So let me introduce to you the characterize to sort technology that we have developed at VITO. See whether this works. It's really a technology designed for complex heterogeneous material streams. And honestly, batteries is one of them. There are many, but batteries highly diverse, a lot of them. Now, the technology consists of three major sensors. On the one hand, we have X-rays. Think about the airport, you can look through materials, very important sensor. The second one is a 3D laser triangulation. It measures the volume of each battery. And the third one is a color camera. With a color camera, you can see colors, and you can also read text. Now, how does it really work? Now take a bunch of batteries. Now not as a bunch like this, that doesn't work. Now let's nicely spread it out on a conveyor belt in what we like to call a monolayer. And a monolayer means no two batteries on top of each other. They need to be nicely spread. And then we send them into our machine and they're being scanned with the different sensors. And then for each individual battery, we will actually start to fuse all the data together from those three different sensors. And that is actually then fed into our AI system. And that AI system is going to extract a lot of features from each individual battery. And based on those features, we can actually do a full classification by chemistry of those batteries. That's the whole idea. And we do that at the same time, not for just one battery, we do it for a lot of batteries. All on a moving conveyor. We're creating digital twins of these batteries. We're providing real-time statistics to the operators. And in the end, we're actually able to physically sort these batteries according to their chemistry. That's what we do. Now that's nice, but you've seen it's an animation, it's the theory. But where are we now? Where are we today? Well, this is where we are today. We are today with a very big VITO prototype at the premises of Sorbat, being the biggest battery sorting plant of the whole of Belgium. This is where we are. We haven't come there out of nothing. Clearly, feasibility studies were done, also in the labs at VITO. But eventually, you need to be there at the center of where it's all happening. And okay, we did not build this up overnight. It took a bit of time. Let's see whether I can show you how it was done. This is a short time lapse where you'll see the buildup of the whole system with all the conveyors, with all the sensors and what have you. And basically this is a very close collaboration between VITO, Sorbat and also a machine builder called Absalem, also a Belgian company. We were bringing this industrial prototype to the floor where all the batteries are sorted. And the real main goal of our prototype was to make our AI models, well, to refine them, to make them better, to make them more robust, to make them faster, to make them more accurate, and to make them smarter, basically. And since we are using machine learning to do that, we need a whole bunch of batteries. We need really large amounts. And which place is better than to go immediately where all the action is taken? So you see even on the screen, the batteries being fed on one end of the machine, coming out at the other end, all being scanned. I would say this is later going to be the heart of the next battery sorting plant, but probably I would better say it's going to be the brains of that sorting plant. And yes, it worked. We were able to scan millions of batteries. We were able to improve our models, and now we are ready. We have our AI models. they have sufficient accuracy so that we can, and not only the accuracy is good, also the speed is fast enough so that now we can actually start upgrading them to a system where we can really sort out batteries based on their chemistry in 7 different classes, exactly the same that humans are doing as well, but in a more future-proof way. Try to imagine what this technology could mean not only in the world of battery sorting, but in other application areas, in other industries. We at VITO, we really believe that this technology could revolutionize the whole recycling industry. So, personally, I spy with my little eye a better future. Love tomorrow. I thank you all.
Danke, Kris Broos. Thank you. Thank you so much. Thank you. This was the longest in my life ever that I listened to talk about batteries, and I still found it interesting.
Thank you.
Really, really. The funny thing is, I had no idea that we were still sorting it by hand, and that you personally made sure that those people didn't have to work again in the battery industry again, right? So, good job or not, I don't know yet, but I do know, that depends, you know, I hope they found a new job, but the fact that nowhere in the world we already have a technology doing this is crazy, right? We've been using batteries since the 1880.
Exactly.
Right?
Yeah.
So can you tell me, you showed a prototype, when is the real thing happening? When is the world's first battery sorting machine really going to be functional?
Quite happy to announce that what we're currently doing is actually, we have taken the prototype and we are rebuilding it into the first industrial sorting line that will be fully functional in 2025 at Sorbat.
So next year, Belgium has a world...
Absolutely.
Perfect.
And it goes further because we're setting up a nice collaboration between Sorbat and VITO, and we actually want to commercialize this technology further. So
of course, you're going to commercialize this. The whole world is going to buy this Belgian quality.
Absolutely.
We will be known for chocolates, priests, and then battery sorting machines.
Absolutely.
Going to be amazing. What is it? Because you say this is going to revolutionize the whole recycling industry. What is the next step? We do batteries, and then what is the next step?
Well, I think other materials are also clearly out there. Now, you have to know I am a metal fan.
You're a metal fan?
I'm not allowed if I can say this here on Tomorrowland, but I'm a metal fan, so it will be metal sorting, I would say.
Metal sorting?
Yes.
Any kind of metal sorting?
Non-ferrous metals, ferrous metals, all mixed metals, I believe. We have to sort them in this way.
So we as Belgians, we can throw our trash, your technology will sort it out, and the world is going to be a clean place again.
Absolutely.
Oh my God. Give him a last applause. Kris Broos, thank you so much.
Thank you.
Thank you, Kris.